What's up, everybody? Back again with another Tesla mechanical design engineer interview question solved. Before we get into it, I have a joke for you. Why can you never trust atoms? Stick around to the end of the video to find out. Alright, so in this problem, a 5 kilogram mass is supported by 3 springs as shown. One heavy spring with spring coefficient of 84 newtons per millimeter and 2 smaller springs of 14 newtons per millimeter each. At what rate do you expect this system to bounce if it is perturbed? Neglect spring mass. So we're going to stick with the same 4-step approach that we've been using to solve these problems. Step 1 is draw a diagram. Step 2 is look at the problem and gather all of the relevant information that we're going to need. Step 3 is based on that information, identify the equations that we could use to solve what's being asked in this problem. And then go ahead and solve those unknowns. And finally, we want to review our problem, go back, find out what's being asked, and actually answer the question. Kicking it off with step 1. We have this 3-spring system, but in order to analyze it, we want to simplify it. So the 2 smaller springs which we have in parallel are going to be combined. And we're going to be left with a system of 2 springs in series. Now we can combine these 2 springs in series to get a 1-spring system. And that's going to be the system that we want to analyze. And so you can see springs 2 and 3 are going to be combined in parallel. And then those are going to be combined with spring 1. And we're going to have this 1-spring system. So moving on to step 2, finding the relevant information. The mass of our system is 5 kilograms. We're ignoring spring mass. The spring coefficient of the heavy spring is 84 newtons per millimeter, and the 2 smaller springs are both 14 newtons per millimeter each for their spring coefficient. On to step 3. Based on the mass and the spring coefficient, you can actually just plug in equations using mass and spring coefficient into Google. These exams that Tesla give you are all OpenNote, open resource, and you're going to find the following 4 equations. Your period, which is 1 repetition of a repetitious motion, is equal to 2 pi times the square root of mass over spring coefficient. Your frequency is just the inverse of your period, so it's just 1 divided by your period. And that is equal to the number of cycles per unit time. And then to simplify springs in parallel, you can just add the spring coefficients. And to simplify springs in series, it's going to be the spring coefficient multiplied together divided by the sum of the spring coefficients. So for the spring system that we're given, we first want to simplify the 2 springs in parallel, so we're going to add the spring coefficient 2 with spring coefficient 3. So that's 14 newtons per millimeter plus 14 newtons per millimeter is 28 newtons per millimeter. Now we need to find the simplified series system, which is going to be 84 newtons per millimeter times 28 newtons per millimeter, our effective spring coefficient for the parallel springs, divided by 84 newtons per millimeter plus 28 newtons per millimeter. And that equals 21 newtons per millimeter. Now to solve for our frequency, because that's what this problem is asking, the rate at which we expect this system to bounce. It's 1 over 2 pi times the square root of our mass, which is 5 kilograms, times our spring coefficient, but we need to find that in newtons per meter. So we do a quick conversion, which you can see on the side. And this gives us 10.31 hertz. Lastly, to step 4, reviewing what this problem is asking for. The rate at which we expect this system to bounce if it is perturbed. So that is indeed our frequency, the number of cycles per unit time. And we solved that to be 10.31 hertz. That wasn't an option in this question, but 10 hertz was. Now, to answer the joke of the day, why can't you trust atoms? Because they make up everything. Hope you enjoyed this video. I'm going to try to get these out every Sunday for those of you who asked. I appreciate you. You know who you are. And if you have any questions, comments, please leave a comment below. Thanks.